All right. Hello, students. It's Mr. Rich. I'm going to work an SAT problem for you, an SAT math problem having to do with a quadratic. Here is the question. It says, when the quadratic function h is graphed in the xy plane, and let's take a look at this. Make sure we get this on here. There we go. Let's do this. So when the quadratic function h is graphed in the xy plane where y equals h of x, let's get this moved down just a bit here. There we go. Its vertex is 2 comma negative 3. One of the x-intercepts of this graph is 11, 4. What is the other x-intercept? Well, the best way to really do this is to maybe picture where this vertex would lie, right? So I'm going to say that it's down here at 2, negative 3. And you always want to keep in mind that these parabolas that come from quadratics are going to be symmetric around their axis of symmetry. So I know that if it's got an x-intercept at 11 over 4, that's going to be at 2 3/4, right? I'm just converting that into a mixed number. So it's going to be over here at 2 3/4. So that means from the vertex, it's going to come up there, but then it's also going to come up on the other side like this. And the thing that I know is that whatever this distance is between the x-coordinate of the vertex and that x-intercept, that distance, which is obviously a distance of 3/4, that has to be how far it is away on the other side. So I would just simply take 2 minus 3/4, and that's going to give me the location of that x-intercept, which is going to be 1 1/4, which would be 5/4 right there. Now, let me show you, and that's it. That's how you would solve this question. Now, the other thing that I wanted to show you here is a mistake that you could possibly make if you thought you were going to use Desmos. If you tell Desmos to make a table and you put the vertex in, because you know that's one of the solutions to the quadratic. So we'll put in 2, negative 3. And if you put that x-intercept in, 11, 4th, 0, and then you tell it to do a quadratic regression, it's going to give you that right there. And it's going to show you the function over here that it just generated. And you can see the vertex isn't where it's supposed to be, or where you thought it might be. No, it made a different function that does pass through over here at 2 3/4, but it's making it pass over here at 0, 0. And that's not one of the options here. And so you can see that that's not going to be our answer. So you would know that at that point, okay, Desmos didn't work because you need to have 3 points, right, to make a unique quadratic. So at any rate, just checking the answer, right? One thing I could do is I could check this answer and give it the third point of 5/4, 0. And there's the new one. And you can see there's going to be our vertex at 2, negative 3. And there's the 2 x-intercepts. And that is my answer. And so one of the tips that I give my students is, as it pertains to Desmos, most of the problems are not going to be optimally solved by Desmos. It's going to be faster if you know the algebra and then the concepts that are required for that particular problem. Desmos is good for checking answers. It is sometimes the most efficient way of solving a complicated problem. But the best test takers, the ones that are scoring well into the 700s and closer to 800, they will tell you that with their algebra methods, they are able to solve most of the problems, maybe with the exception of 1 or 2, and they have extra time left, and they go back and they use Desmos as a check to the answers that they obtained using their algebraic and mathematic methods. Okay, well, that's just one problem I wanted to go over with you today, and thank you for watching. If you have another way of solving this, please put a note down in YouTube. Let me know if there's another method. I've tried several. I think the most efficient one is the one that I showed you here. But check back into my YouTube channel. I'm posting nearly every day a video related to the SAT or sometimes one of the AP math classes. Take care, everybody.